All right, so in this video, what I'm going to do is go through a couple problems with you just to kind of give you a reminder and some suggestions about how you want to approach some of the calculations specifically in the project, your project one that you're doing. So on the screen, you can see I have several questions on here, practice questions for project one. So we're going to go through these three of them here in some detail. I just want to show you how you want to approach these systematically and how you want to set them up, showing all your work. Okay, so the first question gives us some information. All right, so we'll take a look at number one up here. It says the surface of the Earth at the equator moves at a speed of 460 meters per second. We want to convert this to miles per hour. All right, so as with any question, what you want to do is you want to organize the information. So what are you given? Right, so we're given a speed here being equal to 460 meters m per second s. And what we need is we want to convert that to same speed, but in now miles per hour. Okay, so if you take a close look at really what we're doing here, we're performing a couple unit conversions, but we're doing them simultaneously in this problem. So we have a conversion that we're doing in terms of the distance, right, going from meters to miles, and then we're also are going to convert the time, seconds into hours. All right, so we can break this question down into a couple pieces, right? We see there's a distance component, there's a time component, and then we want to establish the relationships that we're going to use to get from where we're starting to where we want to end up. So we want to establish some relationships or some equalities to allow us to do this. Okay, so and again, you can look up some of these equalities in your textbook in the inside back cover or the front cover of your text if you need to, especially as it comes to going from one measuring system to a different measuring system. So let's take a look going first of all from meters into miles. Okay, so meters to miles, that's the numerator here. Now, you may not know how many meters there are in a mile, but we can go through a conduit. We can go through meters to kilometers, and then we can look up in our textbook what the relationship is between kilometers and miles. All right, so this first conversion here involves a metric conversion, so this is one that you should know. 1 kilometer is 1,000 meters. Okay, and then the one that you're going to probably have to look up the relationship between kilometers and miles. We say that 1 kilometer equals 0.621 miles. Okay, so we've established these relationships as equalities. Okay, the metric one that you should know, and then the kilometers to mile relationship that you can look up. What it allows us to do is to get from meters into miles, and that's the top half here of our problem. Okay, so in the second, or the bottom portion of this, is we also need to go from seconds into hours. All right, so we're going to go from seconds to hours. And this, some time conversions that you probably should be familiar with. If you don't know how many seconds there are in an hour, you should probably know how many seconds there are in a minute, and then how many minutes there are in an hour, right? So there's 60 seconds in 1 minute. So we established that as an equality or as a conversion factor, and then there's 60 minutes in 1 hour. That's another equality that we can turn into conversion factors if we wanted to. So what we've done here is we haven't really done any calculation. All we've done is establish some relationships that we're going to use to allow us to solve this problem, and then we can go ahead and set this up. All right, we know where we're going to start. We're going to start with 460 meters per second. Okay, and then we're going to do all of these calculations. We can do them one after the other, so we're not breaking it down into chunks. We can all set it up here at the same time. So you can do either one of these conversions first, either the second to hours or the meters to miles. Let's do the meters to miles first. Okay, so the first step is to go from meters into kilometers. So that's our equality. We're going to stick it in here. And remember now, your units are going to guide you. All right, if you want to end up with kilometers, that's the unit that should go on top. So 1 kilometer or 1,000 meters. So meters go away. All right, so we end up with kilometers on top. We're over here. We want to get to miles. We can then take our second conversion factor and stick it in. And if we want to end up with miles, then we put the 0.621 miles on top. And then that's for every 1 kilometer that goes underneath. So kilometers cancel out. So at this point, right, what you can see is the units that we're left with are miles on top. And the only unit on the bottom is seconds, right? So we're halfway there. We needed to get to miles per hour. So we still need to do the time conversion. And we can do that conversion right here. We don't have to start a new conversion. We can just add it on or attach it to our conversion here. So we want to go now, we have seconds in the denominator down here. We want to convert that to, first of all, minutes in the denominator. All right, so if we want minutes on the bottom, using our equality, we're going to take that one and stick it in. We're going to put the 1 minute on the bottom, because that's the unit that we want underneath. And then we have 60 seconds on top. Okay, and we put it there because the seconds are going to cancel, right? The units are guiding you. And the last step now would be to go from minutes into hours, right? We want to end up with hours as the unit on the bottom. So for every 1 hour, that goes on the bottom, we have 60 minutes on top. Minutes go away, and now the only unit we're left with in the denominator is hours. Right? We have our miles left on top because all the other units cancel out. So in terms of the units now, right, just looking at the units, we have the correct units, miles per hour. All we have to do is to use our calculator and evaluate now all of the numbers here. So we're going to multiply out everything in the numerator and divide it by everything in the denominator. So when we evaluate that, our calculator is going to spit out a number at us, right? So let's see, I'm getting 1028.376 miles per hour. Okay, that's your calculator answer. We need to make sure that we round that to the correct number of significant figures. So let's take a look at our numbers here and make some sense of these. Okay, so if we look here at our time conversions, right, those are all exact. Right, there's exactly 60 seconds in a minute, 60 minutes in an hour. These are all exact. The metric conversion is also exact. Okay, so those are not, that means those are not going to limit your sig figs in your calculation. Okay, what's going to limit our sig figs in this case is our initial number here, which actually has 2 sig figs in it. Okay, so our answer at the end, and by the way, this one here has 3 sig figs. So when it comes to multiplying and dividing, we take the number with the least number of significant figures. So we want to round this to 2 sig figs. All right, so there's our first one, there's our second. The next digit, the 2 is less than 5. So this ends up being 1,000 miles per hour, okay? But we need to make sure that we specify that we do have 2 significant figures. We can convert that to scientific notation to avoid any ambiguity. So we end up with 1.0, which has your 2 sig figs in here, times 10 to the 3 miles per hour, right? So roughly the Earth is revolving, according to what we're told here, the Earth is rotating at a speed of 1,000 miles per hour, right? That's pretty quick. Okay, so let's take a look at another example that is fairly similar and it kind of is along the same mold. So now we're told that the Earth orbits the Sun as it moves around the Sun, and it covers that route at a speed of 33 kilometers per hour, so per second. We need to convert this to miles per hour, right? So again here, when you start these problems, right, list what you're given. So we're given a speed again, in this case of 33, so kilometers per second. And what we need is to convert the speed into miles per hour. All right, so if we chart our conversions here, just like we did in the previous example, right, we want to go from kilometers to miles. And we actually did this in the previous question. We can use our relationship between kilometers and miles, which you can look up. So 1 kilometer equals 0.621 miles. So we can use that equality as our conversion factor. And then the other thing we need to get to, or to get from, we want to go from seconds into hours. Okay, and as we saw before, we can go through minutes, and then minutes to hours, and we're using the same relationships as we used before. 60 seconds is 1 minute, and then 60 minutes in 1 hour. So we can use these just like we did in the previous example. Okay, so let's go ahead and set this up. So we always start with what's given. So we have our 33 kilometers per second. Okay, so again, you can do either one of these conversions first. I'm just choosing to do the kilometers first into miles. Okay, so if we want to end up with miles, the miles go on top. So we have 0.621 miles for every kilometer. So a kilometer goes away, cancels out. So we're at miles per second now as our unit. We want to convert our seconds into hours. So first of all, we're going to convert the seconds into minutes. Okay, we want to cancel out the seconds. So the 60 seconds go on top. 1 minute goes underneath. Seconds cancel all the way back there. And then if you want to end up with hours now as our unit on the bottom, we need to cancel out the minutes. So the 60 minutes go on top. And then we have our 1 hour underneath. So minutes go away. So in terms of our units, right, again, we can confirm the only unit left at the top here is miles, and the only unit left in the denominator is hours. Right, so that's what we needed to get to. So we can just use our calculator and evaluate this, multiply out, and divide. Okay, so that's going to give us a calculator answer that it spits out at us is 73,774.8 miles per hour. Okay, so that's your calculator answer. We need to round that to the correct number of significant figures. Okay, so looking at the numbers that we're provided with, our original number here has 2 sig figs. Okay, this has 3. And again, our time conversions, these are exact numbers. They don't limit your sig figs. Okay, so our original number that has 2 sig figs is what we're going to use here for our final answer. We need to round this to 2 significant figures. Okay, so the 7 and the 3, those are our 2 sig figs. The next digit is 5 or above, so we're going to round that 3 up to 74, and then we replace the remaining digits now with zeros. So 74,000 miles per hour. And again, we can express this in scientific notation to avoid any confusion. 7.4 times 10 to the 1, 2, 3, 4 miles per hour. All right, so that's the speed at which the Earth orbits or moves around the Sun. All right, so we're going to take a look now at another example that has more of a clinical application, something that you may encounter as you're going into your health or nursing careers. You have to administer drugs or medication to patients, for example. You get orders from an attending physician tell you how to or what you need to do for the patient. All right, so it says the doctor writes an order to infuse a solution, and the order reads, infuse 2 liters of D5, half normal saline with 50 milliequivalent potassium chloride over 48 hours. And then the drip factor here is 15, so this means drops per mil, right? That's the abbreviation for drops. And then it asks you how many drops per minute will be administered over that time period. Okay, so in questions like these and any other questions, sometimes the challenging part is just getting started. So, again, listing out what you're given is really a good place to begin questions like these. Usually when you write out information that's provided, it tends to lead you down the correct path of what you're actually going to use to solve this problem. All right, so it says to infuse 2 liters of this thing, whatever that is, normal saline, with whatever this potassium chloride over 48 hours. So what does that mean? It means you're giving 2 liters of this solution over the course of 48 hours, right? So we can say 2 liters given over 48 hours, which is 2 days. All right, so we can express, and as you've seen in the videos in chapter 2, we can express other types of relationships as equalities and as conversion factors as well. They don't just have to be metric relationships. You can get them from all different types of information. All right, we're also told here that the drip factor is 15 drops per mil. Okay, so we're also given, we already wrote that one out, 15 drops per milliliter. Okay, and what do we need? Okay, we need to get 2 drops per minute. All right, so a couple things to keep in mind here. Really, what these questions boil down to, all of the questions actually, boil down to just converting units. Right, so we need to know the relationship between one unit and another unit. So we want to end up with eventually drops in the numerator, minutes in the denominator. Well, let's see what we have to work with, what we're starting off with here. All right, so we have in this first relationship, this first conversion factor or this first equality, we have liters on top, we have hours in the bottom, right? So right away you may think, well, look, we have a unit of time in the denominator that we're given, we have a unit of time in the denominator that we need. Okay, so time is the common factor here. We just need to convert now from the 2 liters per hours. We're going to have to convert that into minutes. Well, do we know the relationship between hours and minutes? Yeah, we already used that in a couple examples before. We saw that 60 minutes, right, equals 1 hour. So that will allow us to convert from hours into minutes. Right, the other thing here that we're given is the other relationship that gives us the unit that we want in the numerator, which is drops, right? The drops are up here, which is where it needs to be in our answer, but you'll notice it also gives us another unit that we don't see in the answer. We're given a unit of volume, which is mils. And we also see a unit of volume in the other relationship given, which is in liters. Right? So we need to eventually get rid of that volume unit in both of these because it's not present in our answer. Well, how do we get rid of things? We cancel them out. Well, can we cancel liters and milliliters? No, they have to be the same, right? So we can convert liters into mils, and then we can cancel it out, the mils, in the second relationship given. All right, so we need to convert liters into milliliters. That's a metric conversion. As you probably know now, there's 1,000 mils in 1 liter. So we can use these relationships to get from these two things that were given into the units here that we want at the very end. So let's go ahead and start. And we can start with any of these two things that were given. as long as the units are on the right side, whether it's in the numerator or in the denominator. Okay, so let's just start with this first one because that's the first one we started with. So we have 2 liters every 48 hours, right? We're given that from the question. So what can we do? Well, we can first of all, we can convert the liters up here into milliliters. So let's take that and stick that in. So if we want to end up with mils, right, 1,000 mils go on top, and then the liters go in the bottom, so liters cancel. So we have milliliters per hours now, and then we can take the other information that's given here, and we can stick that in, because guess what? When we put that in, the milliliters go away. Right, so at this point, the units that we're left with are drops on the numerator, and we have hours in the denominator, right? So we're halfway there. We have drops in the numerator, but we want to have minutes in the denominator. So how do we convert hours into minutes? Well, we want to cancel out the hours. So we're going to take the relationship between minutes and hours and stick it in here. Hours we'll put on top because we want it to cancel out down here, and then that means the 60 minutes are going to go underneath. Right, so now the only unit left in the denominator is minutes, and I have my drops in the numerator. Those are the units that I want. So just based on how I've had this set up, right, the units tell me that I've set it up correctly. And all I'm left to do is to multiply out 2 times 1,000 times 15 divided by 60 times 48. All right, and that's going to give me whatever 10 or so drops per minute. Okay, so in questions like these, right, you want to look closely at the information provided and turn it into a form that's useful, right? And in most cases, that form is a conversion factor or an equality that we've established here. And once you have that, you can use it. You can manipulate it. You can invert it if you want to switch the units from the top to the bottom, or you can use it as is, as long as your units along the way cancel out and you end up with the units that you actually want. Okay, let's take a look at one more question that has sort of a medical or dosing aspect to it. So here again, we're given some information in this question. So it says a doctor orders your patient to start an IV heparin drip at 5 units per kilogram per hour, and to administer a loading bolus dose of 10 units per kilogram IV before initiation of the drip. All right, and then you're told that you're supplied with a heparin bag that reads 12,500 units for 250 mils. The patient weighs 110 pounds. What is the flow rate? You will set the IV pump rate at in units of milliliters per hour. All right, so there's a lot going on in this question. Let's sort of tease out the important information that's useful to us. So let's write again what's given. So we're told that we want to do this, set up this drip at 5 units of heparin per kilogram per hour, right? And you can write your units like this if you have multiple, per this, per that. You can write it like this if you want to. Now, what we want to end up with, right? So we're given that. We're also given a couple other things. So let's write those down actually. We're given the bag, the stock solution or the stock source of heparin reads 12,500 units per 250 mils. Okay, that's the thing you're going to work with. That's your bag of heparin that you're using to set this up. And then we're also told that the patient weighs 110 pounds. Okay, and that's important because your the drip here is per kilogram of body weight of the patient. All right, So that's what we're given. What we need to figure out here is the pump rate in units of milliliters per hour. Okay, those are the units that we want to end up with. And these are all the other units and information that we are provided with. All right, so a couple things here that we can take a look at. All right, so you'll notice here that we do have the units and the things given that are the same in the units that we want. So we have milliliters in this relationship, we have milliliters here, and then we have hours in this relationship, and we have hours over on this side, right? All the other units we have to cancel out. The other thing to keep in mind, right, is the mils is the denominator in something that we're given, but it ends up being the numerator in the thing that we want, right? So that means we're going to have to probably invert this relationship to get the units of milliliters on top, so that it ends up in the same place in the answer that we're trying to get to. All right, so there's several ways to start this problem, several places where we can start it. It doesn't really matter. So let's go ahead and set this up. We can probably start with maybe the weight of the patient, right? So we have 110 pounds. All right, and then you'll notice in order to cancel that out, we have to have pounds somewhere else or another unit of weight or mass. And the only other unit of weight or mass that we see is this one up here, kilograms. All right, so pounds and kilograms don't cancel. We would need to convert, first of all, the pounds into kilograms, right? And that relationship, 1 kilogram is equal to 2.2 pounds. You can look that one up. And we can insert it here. If you want to get kilograms, you put the kilograms on top. If you want to cancel out the pounds, you put the 2.2 pounds underneath. So pounds go away, and we have kilograms. Right, so now we've converted the weight here into the right unit. Then we can go ahead and take the relationship given, and we can stick that in. So we have now 5 units per kilogram per hour. Okay, so now the kilograms go away, and the unit left on the bottom here is just hours. Right, so we have hours now in the right place in the denominator that we needed to have in our answer. Now we need to get rid of the units, right? The actual word here, unit, that's a unit of measurement that we need to get rid of. So let's see. The other relationship that we're going to have to use that has units in it is the 12,500 units per 250 mil. So if we take that one and we put it in here, right, if we want to cancel out the units, the word units in this case, right, we're going to have to take this relationship and flip it. So we're going to put the 12,500 units on the bottom and the denominator, and that leaves the 250 milliliters on top. So guess what? The word units go away, and now the only units that we're left with are milliliters on top. We have hours underneath, right? That is what we want to get to. So our setup here makes sense, right? In terms of the actual units, all the other units cancel out. The only units we're left with is milliliters per hour. So what we're left to do, right, is to multiply out and divide 110 times 1 times 5 times 250 divided by 2.2 times 12,500. All right, so if we evaluate that, that's going to give us a number that we need to round to the correct number of sig figs. So we end up with here 5 milliliters per hour, right? So we have 2 sig figs over here, 2 sig figs here, we got 1 sig fig, and then we have more than 1 sig fig in the last conversion. So our answer here has 1 significant figure. So when you're going through these questions in the project, right, hopefully you've seen my approach in all of these examples is systematic, right? Listing what you're given, whether it's a number or a weight, or whether it's an actual relationship, an equality or a conversion factor, and then listing what we need to get to. And then using the skills of dimensional analysis and these conversion factors to help us get there. And the key thing in these calculations is you keep track of your units. Okay, the units are going to help you figure out what's going to go in each step, where to put things along the way. Don't just put the numbers in your calculation or in your setup. Keep the units along with them to see how they cancel out.